Hi everyone, I am K. Yuvarani, Department of Physics, Arignar College, Arts and Science, Krishnagiri. My topic is electricity and magnetism. What is electricity? Basic definition of electricity given below. Electric charge and electrical force. Electrons have a negative charge. Proton have a positive charge. These charges interact to create an electrical force. Like charges produce repulsive force. Unlike charges produce attractive force. Electrostatic charge. Electrons move from atom to atom to create ions. Positively charged ions result from the loss of electrons. It is called cations. Negatively charged ions result from the gain of electrons. It is called anions. The charge on an ion is called the electrostatic charge. An object becomes electrostatically charged by friction, contact, induction. For example, arbitrary numbers of protons and electrons on a comb and in hair before and after combing. Combing transfers electrons from the hair to the comb by friction, resulting in a negative charge on the comb and a positive charge on the hair. Charging by induction. Electrical conductors and insulators. Electrical conductors are materials that allows free movement of electrons inside. Metals are good conductors of electricity. Silver is the best electrical conductor. Electrical non-inductors are materials that do not allow movement of electrons easily. Examples: wood, rubber. Semiconductors. Semiconductors are materials whose conductivity lies in between those of conductors and insulators. Example: silicon, germanium. How to measuring for electrical charge. The fundamental charge is the electrical charge on an electron and has a magnitude of 1.6021892 into 10 power minus 19 coulomb. The electrical charge is a discrete quantity and it is always measured as Q equal to Ne. Q is current, N is constant, E is charge. Conservation of charge is a fundamental principle which states that charge can neither be created or destroyed but can only move from one atom to another atom. Definitions of Coulomb's law. Electrical force is directly proportional to the product of the electrical charges and inversely proportional to the square of the distance. This is known as Coulomb's law. Mathematically, formula F equal to K into Q1 Q2 divided by D square, where F is electrical force, K is a constant, the value of 9.00 into 10 power 9 Newton per meter square. Q1 represents the electrical charge, D is the distance between the two objects. Electrical force is a vector quantity. Next one, force field. The configuration of space around an object is changed by the presence of an electrical charge. The electrical charge produces a force field called as electrical field. This is Coulomb's law. A map of the electric field can be created by bringing a positive test charge into an electrical field. When brought near a negative charge, the test charge is attracted to the unlike charge, and when brought near a positive charge, the test charge is repelled. You can draw vector arrows to indicate the direction of the electrical field. This is represented by drawing lines of force or electrical field. Next, a positive test charge is used by convention to identify the properties of an electrical field. The vector arrow points in the direction of the force that the test charge would experience. This is electrical lines of force diagram. The electrical lines of force diagram for A negative charge and B positive charge when the charges have the same magnitude as the test charge. Electrical potential. An electrical charge has an electrical field that supported it. In order to move a second charge through the field, work must be done. Bringing a like charge particle into this field will require work since like charges repel each other, and bringing an opposite charged particle into the field will require to the keep the charges separated. The potential difference that is created by doing 1 joule of working in moving 1 coulomb of charge is defined 1 volt. A volt is measure of the potential difference between 2 points. Electrical potential equal to work done divided by charge. Potential difference equal to work divided by charge. The voltage of an electrical charge is the energy transfer per coulomb. Electrical current. Electrical current means the flow of charges, which is analogous to water flow. It is the charge that flows, and the current is defined as the flow of the charge. The electrical circuit contains some device that acts as a source of energy, as it gives charges a higher potential against an electrical field. The charges do work as they flow through the circuit to a lower potential. The charges flow through connecting wires to make a continuous path. A switch is a means of interrupting or completing the circuit. The source of the electrical potential is the voltage source. Basic definitions of electrical resistance. Electrical resistance is the resistance to movement of electrons being accelerated with an energy loss. Materials have the property of reducing a current, and that is electrical resistance. Resistance is a ratio between the potential difference between 2 points and the resulting current, or equal to VI. The ratio of volt by ampere is called an ohm. The relation between voltage, current and resistance is V equal to IR. This is known as Ohm law. The magnitude of the electrical resistance of a conductor depends on 4 variables: the length of the conductor, the cross-sectional area of the conductor, the material of the conductor is made up of, the temperature of the conductor. Electric power and electrical work. All electrical circuits have the 3 parts in common: a voltage source, an electrical device, conducting wires. The work done by a voltage source is equal to the work done by the electrical field in an electrical device. Work equal to power into time. The electrical potential is measured on joules per coulomb, and quantity of charge is measured in coulombs, so that the electrical work is measured in joules. A joule per second is a unit of power called the watt. Power equal to current into potential. P equal to IV. Thank you.